Hello there! Today I will demonstrate two easiest ways of preparing sulfuric acid. This is not a tutorial, do not repeat anything shown in the video. Concentrated sulfuric acid is a highly corrosive, strong oxidant with powerful dehydrating properties. It can turn organic matter to charcoal, and it does not differentiate between sugar and flesh. While diluted sulfuric acid is much less dangerous, it should still be treated with respect. Those same properties are also the reason sulfuric acid is a very versatile and supremely useful reagent. Here is a short list of just a few of its uses. Fertilizers, cleaning agents, lead acid batteries, production of medicine, and many others. Let's make some. One of the easiest ways of preparing sulfuric acid is by electrolysis of copper sulfate. If you dissolve one of those colorful crystals and subject them to a current of sufficient voltage, copper 2+ ions and sulfate 2- ions will separate. Copper ions are attracted to the cathode, where they are reduced to copper metal, while at the anode water is oxidized, releasing oxygen and H+ ions that then combine with SO4 2- ions to form sulfuric acid. After dissolving the copper sulfate, I added a graphite anode and copper cathode. I turned on the power supply, engaged the overcurrent protection mode. This is important because the copper can short the electrodes, and slowly increased the voltage until the cell started to draw a substantial current. Higher voltage will have you draw higher current, which will reduce more copper in a shorter time, but if you go too high, you will start to destroy your anode. At least with graphite this is the case. Saying 6 volts is enough means this could be done with a 6-volt battery that is much cheaper than a DC power supply. But you would run through a number of them if you wish to scale up the operation, so a power supply is better. Here's a time lapse in which you can see everything I mentioned before. Copper depositing on the cathode, oxygen being produced at the anode, and graphite falling off and being mixed in the solution. I let the electrolysis to run overnight. This is what I found in the morning. Good news. All the copper in the solution was reduced and deposited on the cathode. Bad news. Graphite anode is heavily corroded, and now the acid is full of extremely fine graphite particles that go straight through coffee filters and other filter papers I tried to remove it with. I filter the solution and move to the next method. The second easiest method of preparing sulfuric acid is by oxalic acid precipitation. For this, I weighed out 50 grams of iron sulfate heptahydrate and 22.7 grams of oxalic acid. I will dissolve them in minimum amount of water necessary and then simply combine the solutions. Wait for the precipitate to settle and filter off the sulfuric acid that will stay in the solution. Because solubility of both reagents increases with temperature, I will use a hot plate. Now that the solutions are prepared, all that remains is combining them and filtering off the precipitate to separate it from our diluted sulfuric acid. But before I do this, I will also check the pH of both solutions, so we will be able to better track the reaction. Oxalic acid is acidic. Its pH is somewhere between 1 and 2. My solution of iron sulfate is also acidic, but it's closer to 3. Combining those two solutions should get us pH of 0, because the concentration should be somewhere around 0.4 mole per liter. And the sulfuric acid is a strong acid that can undergo protolysis twice. I slowly poured the solution of iron sulfate into the solution of oxalic acid. The order of addition doesn't matter. I only did so because I think it would look better. Now let's separate the precipitate from our sulfuric acid. For filtration, I'll use double stacked coffee filters.
As expected, pH is lower than that of our reagents.
Somewhere between 1 and 0. Hard to tell, but I think it's closer to 0. I put the solution of sulfuric acid into a freezer to cool it down to precipitate more iron oxalate, which I then removed by decanting the solution.
On the left is the solution of sulfuric acid made by electrolysis of copper sulfate. To the right is a solution of sulfuric acid made by oxalic precipitation of iron sulfate. Black and green colors are due to graphite and iron impurities.
Those solutions are still quite dilute, so I will concentrate them by boiling off water. This should also help in removing some of those impurities. Sulfuric acid can be concentrated this way because it has the highest boiling point of all mineral acids. Trying this with hydrochloric or nitric acid would have the opposite effect.
After 2 hours of boiling, I am left with a small amount of thick, oily liquid and a bunch of impurities like the oxalate that crystallized out. I calculated that 50 grams of iron sulfate heptahydrate can yield me about 10 milliliters of concentrated sulfuric acid. So this small amount of liquid tracks with the calculations. I haven't evaporated the acid I made with electrolysis quite to the same amount. So the solution is less concentrated and much less viscous.
The amount of concentrated sulfuric acid that can be made from 50 grams of copper sulfate pentahydrate is close to 11 milliliters. This is because 50 grams of iron sulfate heptahydrate is 0.18 mole, while 50 grams of copper sulfate pentahydrate is 0.2 moles. Therefore, per unit of mass, copper sulfate is more effective and will yield you more acid. Trying to measure the pH of my concentrated acids demonstrates a common shortcoming of pH strips, namely, they don't account for negative pH values. Both methods work, both have their pros and cons, but my personal opinion is that electrolysis of copper sulfate is more suitable for scaled up operations and producing sulfuric acid for one's needs, but oxalic precipitation is more interesting from the chemistry point of view. Thank you for watching, like, subscribe, and see you next week.